Okay, this is worksheet number 2, hypothesis test for the mean, and I'm going to do problem 1. Okay, so we are given right here professor, so take an average of 15 credit hours, believes. Okay, so that's telling us the null hypothesis is going to be 15 credit hours. Okay, and then it's saying a random sample of 24 students, so that's our sample size, and in her class of 250. Okay, so the population size is 250, and so you can check that 24 is less than 10% of 250, so that should be fine. And report the following numbers. Okay, and so we have a set of data here, and it's asking us, does this sample indicate that the students are taking more credit? Okay, so more credit hours, telling us the alternative is going to be greater than the professor. So test an appropriate hypothesis and state your conclusion. Okay, so let's do the test. First thing, hypothesis. So our null would be, see, the belief is 15, so the null hypothesis would be the mean is going to be equal to 15 credit hours. Okay, so we are going to say the statement would be, let me just make it bigger. The statement would be the mean. Okay, I got very bad allergies today. Sorry. The mean credit hours is 15 hours. Okay, per term. Okay, 15 hours per term. Let me just insert that here, per term. Okay, and then the alternative would be, it says right here, it's more, so the mean is greater than 15 hours, and then we write the statement, the mean credit hours is over or greater than 15 hours per term. Okay, there you go. So that's our hypothesis. Then let's go to the model. It's where we write our assumptions and conditions. Again, there are 4 assumptions and conditions, and let me just write it. Okay, so it's got it. Okay, the 24 students were randomly selected. Number 2 is each student's credit hours is independent. Then number 3, we've verified a while ago that the 24 students is less than 10% of 250 right here. And then finally, the nearly normal condition. So again, we need to do some work there for the nearly normal condition. And so we do, okay, I have encoded the, okay, let's name this, we name it, I don't know, CRD, credit hours, HHR. Yes, okay, there you go. Enter. Okay, so again, after you encode the data, you wanna do the one variable stat. So let's do the one variable stat. Go stat, statistics calculations, and do one variable stat. Hit OK, and this would be credit hours. Okay, so the mean is 16.625. Let me write that. 16.625, the X bar, and then the S would be 2.222. It's this one right here, 2.223 hours. Okay. So, and then let's look at the graph. The graph of that. Okay. Credit hours. Again, we want to see if there's no outlier. Okay. So we want to check the box plot. Just take some time to check the box plot. Oh, my bad. Take some time to check the box plot. Okay. Okay, so there's no outlier there. Okay, we got a 5-number summary here. Okay, no outliers, and so let's take a look at the histogram now. Okay, so the histogram looks like unimodal and like roughly symmetric, you know. We could change the bin size, plot properties, and then let's use the bin city settings, and then equal bin, and then if you remember, the standard deviation was 2.2. Okay, so let's just use, we can just use 2 right here. Just use 2 and then hit OK, and then zoom out so we can see the general shape of the sample data distribution. Okay, so it's really like a unimodal, and we could say roughly symmetric. Okay, if you look at the general shape, you have to remember that there are only, again, 24 data. Had we sampled more, or had the professor sampled more, then this would be normal right here. Okay, so we just write, let's continue with our answer. Okay, so the sample size is a moderate. Okay, let me write it first. The 24. Moderate size, but the histogram shows unimodal and symmetric. What am I saying? So I can proceed with using the approximately normal model. Okay, and so I'm going to write now the final statement of the assumptions and conditions. Okay, I'm going to say with conditions met, we assume T model. Okay, T model, because if you notice, the problem doesn't give us the population standard deviation. What the problem gave us is the set of data, and from the data we got our sample standard deviations. Okay, and so we assume T model and perform a one sample T test.